There we go. So we're going to start with going over 1-6 real quick. Y'all seem to do pretty good with the whole is it a function or is it not? The idea is every input goes to one output. Every x goes to one y. Every domain goes to one range. If that's true, it's a function. Yes, sir. We are on 30-something? 35. So, we'll start off with just real quick running through the assignment. You had 4 or 5 days to work on it, which is why it was one of the few times I was okay with us going outside of class with our work. As we had almost a week, right? We got this on what, Friday? It's Tuesday now. Yeah, we had a good chunk of time there. So you don't have to say it the same way that they do. But the idea about this was I could say not a function because 9 maps to -8 and 4. If I had just said that, all right, you're good. Like, it's shorthand. I would hope that you can English, but there you go.
Notice how close we were to the end of this?
Well, yeah, we hit the assignment part, and then I said, okay, go. We didn't have long in class. I think we had like 10.
I'm saying to the end of the pack.
Oh, okay, yeah. Today's section, and then the packet's done. And do a little bit of review stuff before our next quiz. Then we get a new one. But no, that's not for the whole class. Although we are going to do the way that it basically works out in here is packet 1, 2, 3, and 4 are quarters 1, 2, 3, and 4 for the year, for the most part. So it actually works out pretty nice. 10. 35. Okay. 10 is also not a function because zeros go in 2 places. 12 is not a function because you have -9 going 2 different places. But 11 is good. You always know that it's going to be a function if it only says every one of your x's once. Because if I don't press the button more than one time, it doesn't even have the chance to screw up. It just does the one thing. All right. Vertical line test. Remember, you can use like a pencil or an ID. I've had kids use like a calculator lid, the edge of a notebook, something that makes a vertical line. You just run it across your paper and say, does it ever hit it more than once? In this case, every one of these lines, we only hit once. But over here, 0 hits at -4 and at 3. So, nope. And for these, your rationale is just it fails or it passes vertical line test. That's all you need to say. Okay. Next side was blah, 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 same thing but words. Number of students absent from the freshman class, first 5 days of school. Blah, 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 blah. Here's a graph. Is it a function? That's all they're asking, okay? Here's a graph. Is it a function? And I'd say yes because it passes the vertical line test. Okay. Now they said because every x is mapped to one y. Well, that's the formal definition, but I can just say it passes a vertical line test. That's fine. 16, we have a table. If I was going to create a relation with the table, is it a function, yes or no? Well, yeah.
Would you count it if I said no because the 8's not a match?
Right now, yes. Going forward to a quiz, let's change the wording a little bit. Can you elaborate on that? What do you mean by it doesn't match?
Because 1/8 is 50 and the other one's 8.
Say that. Because 8 goes to 50 and to 80. But you're saying what it maps to. Or if you said the 8s don't go to the same number. Doesn't match is just a little vague. It's kind of like if I said, you. I just said you, and I gestured in a direct line that includes 3 kids. Like, who am I talking about, right? You just want to be a little more specific than that. But, yeah, I mean, you're right. You know what you were thinking. Just write a couple more words. Okay. Then vocab. We usually do good with vocab because it's just about going back to that first page and double checking, making sure we're using the right words, the right terminology. At the bottom, these are usually ones that we struggle with because it's completely open-ended. You have to ask yourself a question and then give a reasonable answer, and then put it in a sentence in a math class. Map a relation. 5 number values in the domain, 6 in the range. And so it doesn't even matter what they are. There's 5 things in domain, there's 6 things in range. I already know that has to be not a function. Because I'm saying there's a pop machine that has 5 buttons on it, but 6 different things can come out. Right? Domain, range, input, output. If you have a pop machine that's got 5 buttons, but after pressing all 5 buttons, you have 6 different kinds of pop in front of you, it's not exactly a functional machine. Or maybe more appropriately, it's not a functional guy who filled the machine. So, yeah. I tell you what, if I was one of those like vending machine folks that's always coming around filling them up, I would mess with people. I'd put like the random Sunkissed in the Pepsi slot, just like right in the middle. Why not? But all right. So we went through the thing. How are we feeling about it? Was functions okay? I hope. Get them. You know what? That's a little small up here. Here. Let's do this. Grow up, dude. Okay. You have 3 different representations of relations. One's a graph, one's a mapping, one's just some coordinates. I want you to tell me for each of these 3, they are 3 different functions, represented 3 different ways. Or not functions, they're 3 different relations. Tell me if they're a function or not, and why. That's it. That's your daily quiz. Make sure you label it 1-6 functions. And you know, always. Here, I'll say A, B, and C. So parts A, B, and C, tell me, is it a function or not? And whether it's a function or not, tell me your reasoning. Open notes, open everything. Stay on the bench. Okay. You all do that. I'll be back. Just like these, except it's a continuous graph instead of dots. So, can you do the vertical line test on it? Will it only ever hit the graph once? There you go. Yes, sir.
I forgot what function is. Like just a definition. I can't really find it in the
Part of our problem when we were writing all over this, you didn't write anything. It's kind of spaced out. So,
What was I supposed to write?
well, we wrote some stuff on here to help clarify it. What you need is right here, but we wrote it in our words to make it easier. Since you don't have your words on there, you're going to have to work with theirs. Gross. Flaming hot Funyuns? Like, that is the definition of woke up and chose violence. Flaming hot Funyuns. Okay. Is there anyone still rolling? Okay. All right. That's all right. It's just all the hot stuff that kids always eating. Like, I mean, you do you. So, yeah. Thank you for asking. You good? Okay. I gotta say, like, I'm gonna abuse my podium up here. I'm of strong Irish Norwegian descent, and I have sensory issues. So for me, spice is salt, pepper, butter, ketchup. Like anything more than that, I'm a sissy. Hell, no. No way.
I had the same thing, and there's only one kind of spicy.
Some, like the really weak stuff, the super sweet stuff I can do.
Like tangy barbecue sauce. Can you do that?
It's on the edge. But then there's also like goo. I can't do goo. Like the sauce on the actual meat. Like barbecue sauce or ranch or any of that kind of stuff. Like it just and I yak. I can't do it. Like liquid medicines of any kind. No one likes them. I actually vomit the second I see it getting close to my mouth. So no. I am a very, very, very picky eater. So when I'm seeing kids rolling in with like flaming hot Funyuns and extra nuclear Doritos or whatever that is, like, just whew, that's something. First one. If I take a vertical line right there and I drag that across this graph, will it ever hit it in more than one spot? No. Since that's the case, I will say it is a function But what's my reason? Okay, now you can either say every x maps to one y, or you can say what I think a lot of you did was passes the vertical line test.
I have a question.
And that's perfectly fine. Yes, sir.
Do you take this as an answer? It is a function because one number doesn't go to the two different numbers. Will you accept that?
I don't like saying number twice. I'll take it now.
I can erase it.
But when we get to quizzes, differentiate what you mean by number and number. Say because every no x goes to more than one y.
One number doesn't go to two numbers.
But then you're saying number twice. It's like, hey, do you know the guy with the face? Do you? Do you know who I'm talking about, right? The guy, he does the
I
thing.
have a face.
He does the thing over at that place, right?
Yeah.
Okay, it's too vague.
I know people.
It's too vague to say a number doesn't go to more than one number. But if I say an x doesn't go to more than one y, then I'm being a little more specific and it's okay.
Yes.
Literally the x values and the y values. Okay, so I'm okay with it right now, but make a note to yourself. Maybe even write next to your daily quiz. Say x and y instead of number twice. Okay? What's up? Huh? Oh, whether it's a function or not. If you say yes, passes vertical line test, I'll take that. Yeah. Because that was the question it asked in the directions.
Well, I did that throughout the entire session.
Yeah, that's fine. This one I will say, okay, no, it is not a function because, and I would say -1 maps to 4 and 5. Or I would say because -1 goes to instead of maps to, or -1 results in 4 and 5, or there's an x value that maps to two y values. Some sort of wording like that. And then this one, the fact that it has double 4s actually doesn't matter. The part that matters is I pressed the -3 button and it gave me a -3. I pressed the -3 button again and my garage door opened. Like you pressed the button 2 different times and it did 2 different things. So I would say this one is not a function because -3 maps to -3 and 4. So here's what I'm going to do. Yes, no, no, or function, not a function, not a function. And then because these two had essentially the same answer, just different numbers, they both had an x that mapped to more than one y. I'm going to call that a point, and I'm going to call the vertical line test a point. Okay? So did you have the correct yes or no for all of them? And then did you have vertical line test, and did you have something mapping to more than one y? Or one element of the domain maps to more than one in the range? Or one x goes to two y's? Something like that. Yeah?
You put goes to?
Yeah. Yeah, I'd say because goes to, maps to, imprints on, results in, they all are effectively words that make an arrow. So, yeah, goes to works. Okay? Any questions on it? No. What about C?
I said no because it doesn't map correctly.
Because they wouldn't map correctly.
Yeah, like it didn't map. It would 3 to minus 3. But if it were minus 3.
Oh, it's really close, because if you had said no because -3 doesn't map correctly, then I would definitely do it, because you're specifying which one is the problem. It's kind of like if you bring your car in to get fixed and they literally just point inside the hood and say, well, there's your problem. There's a lot of stuff in there, right? You need to be a little more specific. Was that the only one? Okay. You know, I'll take it because you were able to verbally describe it to me. Like, you knew what you were saying. We just didn't English very well. Okay. By the way, it's what you all have grown up with in your formative years. But do you know the idea of using a random noun as a verb for comedic effect? That's just been the last like 5 or 6 years. I can't adult today. Using a noun as a verb to represent the state of being this noun. For example, I can't school today.
Yeah, can I go home?
Yeah. You can always go home. There's just consequences. That's like, I had a kid ask me before, can you hit him? Yeah. I can hit a kid. Once. I got to make sure it's worth it. Like, I'm not actually going to do it. But I can do it. It doesn't mean that I'm gonna. Although, the idea of me and Jackson here just rolling up in the skate park, like, no. All right. Once you flip her over to 1-7, I think we're going to do just fine with that. Well, meaning I don't know how fast we're going to be able to go. We'll see. But here's a fun thing about functions. Everything that we did so far, you notice how they were all tables or the graphs had dots?
The most easiest things ever.
Well, an equation that comes from a function is that exact same thing, but you connect the dots. That's it. You connect the dots. So this is going to take a couple of different concepts and smash them together. Concept number 1. I know how to plug numbers in for variables. In fact, that's why it's called a variable, because its value can vary. How many times has someone asked you a question and you really don't want to give them the answer, so you say, it depends. Okay? How many times a kid has asked me, hey, I'm going to be gone next Thursday. What are we doing? Depends. Okay. A, look on plan book. B, it really does depend. I don't know. It depends whether today is a 1-day lesson or a 2-day lesson. Right? That means that what happens next week is variable. What happens can vary. It can change. Well, if I list a whole bunch of things for my variable, then those are the numbers I'm going to replace my variable with. Then I just got to do the order of operations. Y'all remember old school order of operations? Maybe.
No.
Let's write them off to the side here. You got a little room? You probably remember this. The order of operations, PEMDAS. Please execute my deranged adolescent sister. Parentheses, exponents, multiplication, division, addition, and subtraction. Okay? It's not done. This is probably what most of your teachers showed you. But this being hammered into people's heads for hundreds of years has led to what I call Facebook math.
Don't bring this up again.
Right?
Don't you bring this
Right?
up again.
What is it? Figure it out. Argue.
How can you tell if it's not 9/3 or 9/10?
Argue. Figure it out.
The answer to it is 18.
Come on.
Nope.
Figure it out.
No, because for multiplication and division, you do it at the same time, whichever one comes first in the
It's
equation.
2.
And same
Okay.
for plus and minus. So
It's
the answer
2.
is 18.
2.
The answer is 18.
It's a number divided by 3 times 6.
Now, we talked about this before, right?
It's multiplication and division.
Okay. Landon, say that again.
The multiplication and division, you do it in whichever order it comes first, because you're basically doing the same thing just either way. And then the same thing for the plus and minus. You do it.
I don't actually divide. Okay, now this is a way out there math thing. This is like another 13, 14 math classes past where you're at right now. But you do something called proving why math itself works, and it turns out that there is no such thing as divide. Division doesn't actually exist. It's a lie. Sorry. Okay, I don't actually divide by 3. I multiply by 1/3. Okay, y'all remember that. Dividing by fractions is easy as pie. Flip the second and multiply. Okay, AJ knows. Okay, well, get used to it because it's going to happen a lot in here. Okay, dividing by fractions is not actually dividing by a fraction. It's multiplying by a reciprocal. Same thing goes for subtracting. I don't actually subtract 5. I add 5 negatives. So next to this, I would like you to write multiplication, division is left to right as you encounter them. Addition, subtraction is left to right as you encounter them. Because there is no such thing as divide. You multiply by a reciprocal. There is no such thing as subtract. I add the opposite. Okay? And that's important for some of the scratch work that we're going to be doing today. I have to understand that my order of operations have this little catch, this little fine print with them. And it's something that not enough teachers tell kids, especially in middle school when you're doing a lot of that order of operations work. You're probably doing quite a bit of it. Okay, it's important to know this. All right. Now, if I've got that, okay, see, the reason people will screw this up is they think it's 9 over 3 times 6. But when you do that, you effectively put a set of parentheses there. You added something into the expression that wasn't there. So you'll get people, like a bunch of middle-aged Chads and Beckys arguing on Facebook about this. Okay, so it's a thing. Make sure you have your order of operations written down because we're going to need them as we're going through our tables today. Yes, sir?
What do you want to know? What's the answers to the last question? To the last problem.
9 times a third is 3. 3 times 6 is 18.
I got it correct.
Okay, it is 18, not 1/2. So, we got our order of operations. Those are going to come in handy because if I have x's, I can plug them in and find out y. You're going to start hearing this a lot in this class. If you have an x, you better find out y. Life advice. Okay? If I know that this is an equation, it says my y's are always half of my x, and then tack 3 on there. It's called a linear equation because it makes a line. And this is very, very common in your life. This is why Algebra 1 is required to graduate. Because linear equations are something that happens every single day. Case in point, I get a membership at the rec center. And now all of the classes that I was going to sign up for myself, maybe I'm going to do a little yoga, get my stretch back. There we go. And okay, this wasn't always here. I used to be pretty flexible. In high school, I could do the thing where I'd like just randomly, whoop, and I'd have my foot over my head. Yeah, I was that guy. I'm going to do some classes. Maybe I'm going to put my kids in some of the swim lessons, stuff like that, and it's cheaper if I get the membership. What happens if it's $300 for the membership, but then it's $20 for every class?
It depends on how many classes you take.
It depends. It varies, right? My cost is $20 per class plus that $300 that I had to spend no matter what. It's a linear equation. So these are the most common ways that you're going to see algebra in real world. But you got to know how to work them first. Pretty simple. I got to do some scratch work on the side. You probably remember seeing this instead of this table. How about like this? That look familiar?
No.
Yeah.
Where you did all of your scratch work in the middle? You would say this is going to be 1/2 times -4 plus 3. What's half of -4? -2. -2 plus 3. 1. What is half of -2? Oh God. Okay. Plus 3. -1 plus 3. If you don't know what this is off the top of your head because you're having trouble with integers, get a calculator. Why don't you have a calculator? You're in a math class. Okay? So I'm going to have to do a little bit of work like this. Maybe I can let the calculator run it for me. Maybe, you know what, I won't even use the good one. I'll use the crappy one. Where's trash? Where's trash? There's trash. You put it on the other screen, didn't you? Screw you, Frank. All right. Come on, Frank. Come on, Frank. There you go. Whoop. There. Trash calculator, good calculator. Okay. So, y'all know just on here you can change it to a different type. Okay. I can type 1/2, so 1 divided by 2 goes in parentheses. 1/2. Oh, yes it is, sir. And then I plug in times my 4 negative. Now, does this calculator need negative and then 4 or 4 then negative?
4 then negative.
Yeah, it does. Screw you, Frank. I hate this trash calculator. Times 4 negative. There we go. Is, and then I add 3. Okay, you can let the calculator do the work for you. I don't care, but you have to be good enough to use it. Now, I said this is a trash calculator. That's because I would much, much rather come to this calculator and just type a actual fraction, 1/2 by -4 plus 3. And fun part about that is I can highlight and say do the same thing, but I want you to do it with 2. Do the same thing, but I want you to do it with 0. And just keep going, okay? So where's everyone's calculator? If you are going to use a calculator on your phone, that is fine. If I even suspect that you're doing something else, we got problems, okay? So, that's it. Once I have all of my y's that go with my x's, come on, Frank, I plot all my points. To plot all my points, hey, how many of us have that written down? That x, y, that x is negative, positive like this. That y is positive, negative like that. If you don't have it written down, I suggest you put it right here because you're going to be doing a lot of graphing. Okay? So, you can't say wait when I already picked up, like, the body's on autopilot, dude. Especially lately. I've been staying up late trying to get that desk done. In my house, if you want anything accomplished, you have to sacrifice sleep. Okay, we good? So, 1/7 is literally the tables that we were doing before. Now we got to make them. Once we make them, we're going to plot the points, connect the dots. That's it. Can I erase it or is someone going to freak out? Okay. So we come on down here. They already filled out the table for us. Nice and easy. Just plot points. So, -8, 3. Which direction am I going? -8. Up, down, left, or right? Should be more than 1 or 2 people saying this, right? Going to go left 8 and maybe we can actually put that. Left 8 up 3. Left 8 up 3. Maybe I can say left 4 up 2. Maybe I can say no left or right up 1. Uh-oh, now it's +4. Where am I going? So say that. Right 4, no up or down. Right 8, down 1. Before you go connecting the dots, everyone in this room should have a straight edge. At the bare minimum, every student is supposed to have their ID on them. That's what I do. I grab that and I slap that on my paper and use that as my straight edge. because I've always got it. You've all got your ID, maybe a driver's license, debit card, Qdoba gift card, I don't care. You've got something. Use the straight edge to connect the dots. Don't wing it. Because I've seen some of your handwriting. Winging it is not going to go well. Okay. Connect the dots. You now have an equation graphed. Okay. Bad wing it. No wing it. Okay. Y'all got something. I've had kids use the edge of their phone case if it's straight enough. I don't care. Use the edge of your notebook.
Or use this.
Okay, edge of the calculator. Like that little manila insert inside your books. It's got a straight edge to it. Use it. Okay. Plot the points, connect the points. That's all I'm asking. Okay, round 2. Ooh, that didn't get much bigger. Okay, they're going to give me a word problem example of this where I got to fill in the table. This is actually a pretty reasonable example of a linear equation, too. Boat rental store says you can rent a boat for $50 plus $25 an hour. How many have been to Pactola? You go down by the marina, right? You can rent a boat there. It ain't going to cost this cheap. Not even close. But maybe you could rent a paddle boat like that. Not even a paddle boat? Oof. That was brutal. Okay. We're going to give you a couple of chemical jugs duct taped underneath a pallet. Have fun. That's what we did on the pond back home. You're going to rent a boat for $50 plus $25 an hour. I usually do this in my algebra classes. I call it rate x plus start. It's a pretty common version of linear equations. A rate and a starting amount. Think about if you get a new phone. You have to pay so much to set it up, and then it's so much per month, right? That's your total cost. How much did you pay up front, and then how much a month after that? So they tell me if you're going to pay $50 and then $25 an hour, that it is that equation. The cost in terms of the hours that you use it. Wait, did they say $25 an hour?
It's $25.
Yeah, but look at their equation. They screwed up. They screwed up pretty bad. All right, well, let's see if we can find an equivalent color. Close enough? But now it's written backwards, right? So maybe I'll do C of x is 25x plus 50. There we go. Scribble it out and write the real one. They screwed up. Way to go, editing publisher. So, $50 plus 25x. So, when I say x is 0, shove in a 0. What's 25 times nothing? Nothing. Plus 50. So 0, 50 is my coordinate. Fill in the rest of it. Let's see what you got. Plug in your 1, 2, and 3. See if you can fill in the rest of those. They said x is 0, 1, 2, and 3. They're going to rent this boat for 0, 1, 2, and 3 hours. See, they charge you $50 to even say, I have this boat. Another common example of this, especially this time of year, would be HVAC, heating technicians. You know how many people this time of year try turning their heat on for the first time? And then it's not working, they go and call the guy. The guy says, cool, I'm going to charge you $60 for the home visit, but then my rate is $65 an hour. And it turns out you just didn't clean the sensor and keep the pilot light on like you were supposed to. Thank you, that'll be $125. It took him 10 minutes in reading the instructions on the front of your heater. Okay? This rate X plus start is very, very, very common. What's 25 times 1? And then plus 50. 25 times 2. 50. 50 plus 50. 25 times 3. 75 plus 50. And because these are linear equations, odds are you're going to start seeing a pattern with them. How many of you, after seeing 50, 75, 100, you didn't even have to do the math, you knew what was coming next? Right? So, if you see the pattern, it can help you through the tables. Now that I've got this table, I've got a whole bunch of coordinates that I'm going to graph. I want you to plot those points. We had 0, 50. 1 what? 175? 2 what? Fill the other one in. 3 what? You got a straight edge? Connect the dots. Connect the dots and it'll show you the trend of this line. It's going to show you where it's going. It's going to take off into the wild blue yonder. Like that. Yes, sir. Yeah. Now, I put the arrow going that way. Why didn't I put it going the other way? Well, the numbers do go up, but can't I also pick other numbers like -1 and -2 and -38? What was X in this problem? What was the thing I kept putting on the blank? Was it chalupas? Was it hours? Can I rent a boat for -2 hours? It doesn't make sense. So even though technically the equation keeps going back this way, we don't actually want to put that part on the graph because it doesn't make sense. I can't rent the boat for -1 hours. What am I going to do? You're going to pay me $25 and then I'm going to say, no, I'll keep that yesterday. Like, it just doesn't make sense. So that's why we're not actually going to graph the back half of the equation because it doesn't make sense in the problem. Yes, sir?
Say you're the one that has you're renting someone else for an hour.
Well, now it's an entirely different problem, isn't it? An entirely different equation. I can't let someone borrow my... Okay. Chloe's got a biology test. She He wants to borrow my slinky. Can I let you borrow this -2 days ago? No, that already happened. Okay? In the context of a word problem, you often have to get rid of things that don't make sense. And that's why I only have my equation going from 0 onward. All right. Down at the bottom here, I've got a table. There's the equation. They already made the table for me. Can you plot the points? Before you go plotting points, stop. Look at the graph. Look at the y-axis. What are they doing? They're going by twos. Jerks. That's going to change everything, doesn't it? Whenever that happens, what I strongly recommend you do, especially for twos, is I want you to come in here and make little tick marks to remind yourself that. Tick, tock, tick, tock, tick, tock. Steal your data. Steal your data. There it is. Okay? Now that I have a bunch of these little tick marks that show me I'm counting by twos, I need to be a little more careful when I put my points on there. So when I say -4, -3, y'all cool with maybe writing this next to it just to remind myself where I'm going? Left 4, down 3. So left 4, careful, down 3 is down 1, 2, 3. Right there. You have to be careful about the scale. This is going to be a recurring theme for about the next, I don't know, 6 months. You have to watch the scale. Okay. -2, 1. I'm going left 2, up 1. So left 2, up 1 is only halfway through the box, right? Because they're counting by twos. Halfway to 2 is 1. So my dot's only halfway through the box. I have to be careful about that. Can you finish the other 3?
Yes.
Do it. Put the other 3 on there. Make sure you put them in the right spots. Yes, sir. Yes. Sucking down that like 32-ounce slushy from McDonald's over there. Okay. Get those other 3 points on there. Okay, 0, 5. I don't go left or right at all, but I will head up 5. Use those little tick marks and count. 1, 2, 3, 4, 5. Right 1, up 7. Count right 1 and up 2, 4, 6, 7. Right 2, up 9. Right 2, up 2, 4, 6, 8. Not 10. 9. You notice that all these odd numbers were halfway through the box. This is going to happen a lot. They're going to change the scale on us. It might not be by twos. Maybe they go by threes. Maybe they go by fives. Hundreds. Okay, changing the scale of the graph really changes what it means. Get your straight edge. Hope you don't suck. Yeah, that ain't bad for freehand. Yes, I'm 37 years old and proud of drawing a straight line. Okay? Just getting the image of my 4-year-old at the table with his like dry erase letters. I did it! And there's like it not even close to an A. Yeah, you did, bud. Good job. All right. Backside. Now we're going to complete the table. The table's not done for us. Oh, got my tick marks there. You're going to plug in the values. They have them there for us. So you got to plug them in. They said put a -1 here, a 0 here, a 1 here, a 2 here, 3 here, a 4 here. But now you got to figure out what is -2 times -1? No. Times, not adding. -2 times -1. +2. Oh, do we need to off to the side? Remember, positive times positive is what? Positive times negative. Negative times negative. And negative times positive. Okay, if we got to do that, there's a chair there. Okay, so -2 times -1 is a +2. Plus 6. Thank you. Do it again. What's -2 times 0? Plus 6. -2 times 1. What's 5 times 1? What's 8 times 1? 300 times 1. -2 times 1. -2. Plus 6. So you owe me $2. You find 6. Now you're at 4. Fill in the rest of the table. You see the pattern already? What are they doing every time? What are they doing every time? 8, 6, 4. Counting by twos, downward, right? So then 2, 0, careful. -2. Now those tables, there's different ways to do them. For example, when you come up to the big leagues, maybe we show you how to just get the table. Okay? There's a lot of cool tools out there, but you got to know how to you have to understand how they work in the first place. It's kind of like I can't just hop in a vehicle and go. That's why driver's ed exists. Because they tell you, hey, if you're going to do the thing, maybe you should know some of the rules first. Okay? Now that I've got all these, can you plot them on here with all of those by twos? Do we need to write on here? Left, nowhere, right, 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 right? Do I need to say up, 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 nowhere, down, to remind myself of the directions. If you need it, use it. If you don't, don't. Do what works for you. Okay? This says I'm going to go left 1 up 8. So I'll do left 1 up 8. No left or right, up 6. No left or right, up 6. Then 4, then 2, then 0, then -2. Grab your straight edge, connect the dots. We went the other way. Oh, I got you. I got you. Wait, did I do that wrong?
Yes. Yeah, you did it wrong. It's
No, sir.
Yeah, it's
It's supposed to be the other way.
God, y'all gotta wake up. Come on. Okay. I heard not a peep. Nothing. Until AJ went cross-eyed. He's like, I did the whole thing wrong. Like, who says I did it right? No one said anything. Challenge me. You're still sitting at 5 points. We're almost at a quarter. Get me. Please.
this is the class you make the least mistakes in.
-1, 8, 6, 4, 2, 0, -2. Okay. I want you to stop me when something doesn't make sense. I don't want you to just stare at it and say, well, he's like bald, so he must be right. Like, don't just assume. I want you to be engaged in this. Now that I got all my points up there, connect the dots. If I see the pattern, could I make more dots? I see what's going on now, so can't I add more to extend my pattern? Right? I want you to look at where my line is and how far I went. This pattern is going to go forever because I can pick any number I want for x. They pick nice numbers in the middle of the graph. Is there anything wrong with me sticking 538.6 in there? That's 575.2 plus 6, 569.6. Okay. I'm still going to get an answer. It's about 300 feet that way, but it exists. Wait, no, that way, because I said negative. Okay. I'm doing everything backwards up here. Like my left is your right is my left, upside down, inside out. Someday I will permanently go cross-eyed just from being up here. How many of you have a line right now on your paper that's only like that big? And you just stopped? Or did you take it all the way across the graph, past the edges, and then what should we also put on there since this goes forever? Put little arrows on there. They don't have to be fancy ones. Just put tiny little arrows on the edges of it to say this goes forever. Okay? So, both of these They give you the x's. You're going to plug them in and get the y's. Now, I'm going to walk through 3 with you because kids freak out with fractions. When I say a quarter of a something, it means divide by 4, right? Like a quarter of the day, a quarter of the school year, a quarter of your wage, a quarter of your paycheck. Okay, means divided by 4, right?
Stop giving me nightmares.
So what is a quarter of 8?
2.
2, right? 8 divided by 4. So what's a quarter of negative 8? Negative 2. This says 3 quarters of it. So if 1 quarter of it is negative 2, what is 3 quarters of it? Negative 6, right? So the way that you can do these without resorting to the calculator is you say negative 8 divided by 4 is negative 2 times 3 is negative 6. Negative 6 minus 2 is negative 8. Now, do I have to do that? Or can I grab lame calculator over here and say parenthesis 3 divided by 4 is times 8 negative is minus 2 is. I can let the calculator do the work for me. I don't have to do it mental math. What's a quarter of 4? 1, right? I got $4. What's a quarter of it? 1. So what's a quarter of negative 4? What's 3 of those? Negative 3. Minus 2. All right. What's anything times 0? Minus 2. Negative 2. It happens. Okay. What is a quarter of positive 4?
1.
Right? 4 divided by 4? 1. Times 3.
Times 2.
What's 1 times 3? 3. Subtract 2. Okay. What is a quarter of 8 times 3? 6. Minus 2. 4. I now have coordinates. The coordinates tell me to go left 8, down 8. Left 4, down 5. No up or no left or right, down 2. Right 4, up 1. Right 8, up 4. So I plot my points. Oh. Uh-oh. How do I go left 8 and down 8 on that graph? I can't. Sometimes as we're filling out a table, we'll get values that don't fit on our graph. So just don't do them. Can I fit left 4 down 5?
Yes.
Yes. Left 4 down 5. No left or right, down 2. Right 4 up 1. Right 8 up 4. Ah, crud. Can't do that one either. But do I have enough points to see where my line is going?
Yes.
In fact, this is something that should have been kind of pounded into your head last year. You should have at least 3 points when you're making your lines. 2 points technically is all you need to make the line, but if one of them's wrong, the whole line is wrong. But if I have 3 points, okay, like look right here. Okay, I kind of look like that meme where that gal's like, right? If I'm in a line right here, straight through Riley, all 3 of them are in this line. Caden, I want you to shift about 6 inches to the left. Okay, now, when I try to make this line, I'm like, wait a second. Like, Caden's like not in line, right? So then I come over here and I line up with those 2. Oh, well, now Dylan's out of line. Well, now I'll line up over here. And I'm like, well, crap, now I got Jackson instead of Riley. Like, the whole thing's messed up because I had 3 to compare. If I've got 3 to compare, I can tell if I screwed one up. But if I only have 2, I don't have that comparison. I got 3 points. I can make a line. Y'all got your straight edge? Make your line. Okay. I want you to try number 4. It's this number divided by 3. Or negative this number divided by 3. Okay? What's this divided by 3? This divided by 3. This divided by 3, and then change all their signs. Stop it. I have 0 pop left here. And I'm going to share it with you 3. How much do y'all get? Right? 0 divided by any number is still 0. You got it done?
I got that. I had a coordinator or whatever about
Plot your points on there, and then you go.
So it's this divided by 3.
Yep. Watch your signs on these. Pay attention to how many negatives.
How do I get rid of this?
When in doubt, quit. You're going to be running ahead to what we're doing on Thursday. Look at the time, dude.
Then for 0, 0, would that just be like
Right smack in the middle. No left, no right, no up, no down. Just, you are here. He's working out for you? Okay. Well, you were also like cursing and grumbly, so I want to make sure that we're like, we made an oops. Now we're good with the oops? Okay. So, y'all got to be really careful with those signs. There's a negative in front of this. So when I take -6 divided by 3, what is that?
-2.
But then there's a negative in front of it. So what's a negative? -2. +2. What?
The solution is that you a negative and a negative turns into a positive, so you just do 6.
Okay. And if we were writing out our work like that, that's exactly what we would do. We would say a negative -6 over 3. Change, and then say 6 divided by 3. Okay. But because negative times negative is a -1 times -1, that's multiplication. Multiplication is commutative. The order doesn't matter. That's why we did all that property stuff. What? Okay. What's a -3 divided by 3?
-1.
And then the negative is 1. What's 0 divided by 3?
0.
And what happens when I do a -0?
Can't.
It's still 0.
It's illegal.
Okay. And then 3 divided by 3 is 1, but negative. 6 divided by 3 is 2, but negative. Plot your points. Back 6, up 2. Back 3. How do I do 3? I don't see 3.
I did it the wrong way. You do it halfway.
Right? Just like we did with our y-axis, we can do the same thing with our x.
Oh, I was a -3 divided by.
If it helps you to make these little tick marks, so you remember that, you have to watch their scale. So if I go back 6, up, wait, that's not 2, that's 1. Put it right there. Say back 3, up 1. So 1, 2, 3, up 1. How do I do 0, 0? What?
Oh, can I use Russian now?
Oh, yeah.
I got a -2.
For which one?
For -6 divided by 3.
But there's a negative in front of it. When I put -6 over 2 like this is -3. Wait, why did I said 2, and then I said, God, I'm tired. -6 divided by 3 is -2. So it's a -2. Right? You take care of the part inside, and then this guy, he's causing problems. Whatever you say, opposite land. Okay? And then we have 0, 0, which is right smack in the middle. Right 3, down 1. And right 6, down 2. Connect the dots. A line of tomato soup. So, or at least that's what it looks like to me. It's about that color. We ain't going to go any further. No homework. When you come back on Thursday, we're just going to finish this off and then in class time to work on the assignment. Okay? Yes, and there is no school Friday, so enjoy it. First semester, there's a bunch of breaks all over the place. Second semester, there's like random 6-week-long grinds. It's rough. What you got, bud?
Pretty sure these are